Hey there, minions. Let's get back to work. Whoa, just got a big scroll going on. We're working on, this is 5.3, Fundamental Theorem of Calculus. We're going to do part one. This is our second video. We're going to say if f of x is continuous on AB, we're going to say f of x. Notice this is with t. F of t dt. So the variable of integration is t. And our x is in the limit. And A is the bottom part of the interval, okay? So X is somewhere in like AB. We got a number line AB, and there's an X in it, and we're kind of like doing the integral up to that point kind of thing. Okay? So f of x equals this big integral a to x of f of t dt. If I take the derivative of both sides, I get f prime of x, and that's going to apply a ddx right there. And this ends up being f of x. That's the fundamental theorem of calculus. Applying the derivative on something with a to the x, f of t dt, equals the inner function evaluated at x. Oh, wow, that's blurring all out. We're going to prove it real quick. So we're going to say f of x does equal this. And we're going to show that f prime of x, when we take the derivative, it actually equals f of x. That's what we're going to do. But that is the fundamental theorem. Oh, that's crazy looking. Why did you not make a rectangle? There we go. That's the fundamental theorem. All right, so we're going to prove it. We're going to use f of x equals that integral. Let's take the derivative of both sides. And we're going to use the limit definition. It's been a while since you guys have done the limit definition. Remember, the limit definition is the derivative of something is the limit as h goes to 0 of f of x plus h minus f of x over h. That was our limit definition way, way back in the beginning of the semester. Remember that? So we're going to do that here. The only spot x shows up, though, is right here. So that's where our x plus h goes, and our x. And here, like we did previously, I just factored out, put the 1 over h out front. Okay. And now I'm going to switch the order. I'm going to flip the order of this one. So if I want to make x on bottom and a on top, I got to introduce a negative sign. Remember doing this in last chapter or last section? So if we do that, we can do that. But now notice I got a here and a here. This was like when we had a to c plus c to b. We could just make that equal a to b. This was also in the last section. So that's what we're going to do here. A here is my x, and x plus h is my b. To match that up, x plus h is my b, and x is my a. And these are my c's. Okay? So like it looks like it's sitting in the wrong order. But when I do that, I can compress it down to like this. Okay? recall f average. We had 1 over b minus a from the integral from a to b f of x dx. We're going to apply that here. And so my b here is that, and my a is that. So when I do b minus a, I get 1 over h. And I got this here, and there must be, it means there's an f of c. This is what we just did in the last video, recall? The mean value theorem for integrals. F average equals FC. There's somewhere in the interval that it equals. So we're going to use that. We're going to say, we're going back up here. I'm missing something there. Nope, I got the 1 over h right there. That is that, which equals that. So we're going to put it right there. So we got limit as h goes to 0 equals f of c, or not, limit h goes to 0 of f of c. But on x and x plus h, as h goes to 0, let's take a picture or look at this timeline here. I want a different color. I got x here, and I got x plus h here. As h goes to 0, and we got c in the middle. C's in the middle. As h goes to 0, this goes this way as h goes to 0, which kind of forces c to go that way too, right? And when h gets all the way down to there, it looks like c is approaching x. So as h goes to 0, c goes to x. By our little number line, we can see that. So I'm going to rewrite that limit as c go to x of f of c. So f prime of x equals the limit as c goes to x of f of c. We just plug in the c as x because it's a continuous function. And we get f prime of x equals f of x. Bam, done. So I want you guys to, we're going to do some exercise where you practice doing this. Just figuring out what the integral is. So find, in this case, find g prime of x if g of x is the integral of from 13 to x of z squared plus 4 dz. So g of x equals that. G prime of x, we're going to take the derivative by using the fundamental theorem of calculus part 1. What happens is, and you'll notice that here, well, let's look up here, this just gets put in for the t. So that's what's going to happen here. X just gets put in for the variable of integration, which is z. So we put the x in for z, we get x squared plus 4 in the square root, and we're done. It's really simple. This has to be a constant. Remember that, okay? All right, find f prime of x if f of x equals the integral from 1 to square root of x. Now this is a little trickier, because that's x, and the fundamental theorem applies to x there, but we've got square root of x here, so we gotta be careful. So we're gonna say, we're gonna make it look like it. We're gonna make an integral that says like 1 over u sine u du. None of those look like u's. They all look like sloppy a's. We're going to do that. And then the rule will, not u, this is still t. And then we'll be able to plug in u, okay? So we're going to say u equals the square root of x. And when we take the derivative, we end up getting a chain rule. Because we're doing d dx, applying it to this, but we have a u in there, so we got another variable. So we got to do a du dt in there as well, or du dx in there. This is doing du dx, dx dt kind of thing to give us our du dt. It's kind of like that. So what was du dx? Well, u is x to the 1/2, so du dx is 1/2 x to the negative 1/2. We're going to put that in. And now that we have this in terms of u, we can go directly to it. We got sine u. That's just using the fundamental theorem, but we got an extra chain rule on there. So we put that there at the end, and I just put it out front and cleaned it up, and that will be our f of x. It's a little tricky. So if it's not an x up there, you got to do a chain rule. So try it here. We don't have x up there. We've got x cubed. Oh, that was a yawn. I use w as my variable of integration here. We've got f of x equals 1 to x cubed cosine w dw. Try doing what we just did right here. Try doing that real quick. Hit pause. All right, I'll assume you did. We could plug it directly in, get a cosine of x cubed, but we got to do a du dx. So I'm going to say u equals x cubed, du dx equals 3x squared. So when I do the fundamental theorem of calculus part 1, I get cosine u du dx. We substitute in what we have, and we get 3x squared cosine of x cubed. Okay. Oh, this is fun. Look at this. We got x to 3x. This is tricky. Check this out. So what we're going to do is we want to do this. We want to take the derivative and use the fundamental theorem, but we got some stuff going on. So what we're going to do is we're going to split this up, and we need a constant down here. Remember, this needs to be a constant and that needs to be x, and we don't have that. So what we're going to do is I put 0, I shouldn't have. I'm going to put a here. We're going to split that up. We've got x, 3x, and an a in the middle, and we're going to do one integral there, one integral there. Okay? So I split up my integral. That's all I've done so far. Split it up. This one's in the wrong order. Remember, we need x on top and a constant on bottom. And this one is not x, it's 3x. So this one is going to require a du dx, the chain rule. So we're going to have to do both of those. Here, I switch this one by just flip the order and put in a negative sign. And then I made a note of what we're doing. We got u equals 3x, so du dx equals 3. Now that this is in the right order, this one, the negative comes down, x just gets put in for t, and we get negative 4x cubed. Here, we got to do, when we do it, we're doing our u sub, we'll be able to put the 3x directly in if we have a du dx here. So remember to bring that down. I put it in, I wrote in the u just to show that it's there. And then this step turns into 4u cubed times du dx. And this wasn't a trivial thing, so I took my time with it. U is 3x, and we're cubing it. So remember that the cube's got to hit the 3, and it's got to hit the x. So 3 cubed is 27. So 3x cubed is 27x cubed. That right there is just that right there. Here, I multiplied the 3 by the 4 to get the 12. And now we got 12 times 27, that's 324. They're now both x cubed, so we can add them together, and we end up with 320x cubed. Okay? And that's it for that one. We're about ready to start the best thing about calculus right here. It's coming up. I gotta stop recording. We're gonna do another video for that one, for fundamental theorem part 2. Peace.